Okay. Let's see if we've got the same setup here. If I am indeed live yet. It hasn't updated on YouTube. Oh, speaking of which, it's gonna be I'm gonna be hearing myself. Oh. Not yet. Oh. Nothing yet. Oh, there we go. Let's hear how it starts. Oh. Okay. Okay. My bad. We're good. Oh, whoops, I paused that instead. Gotta make sure the levels are good. We're gonna mute me first, and then I'm just gonna keep that playing. Let it play a little bit. Alright, cool. I think I've come to realize it's very, very quiet. I almost want to see if there's like, if I could just boost the gain on my mic to make it always 0 decibels. Then again, it is 0 decibels. It shouldn't be that quiet. Oh, but all the YouTube videos are quiet. I have my volume down because my music is loud. Alright, let's have a listen to that, shall we? Oh, dang it. I have to go back. Alright, not bad. Alright, I'm going to go forward. Mute it. There we go. Alright, live playing. Cool. We're going to turn down the volume to 0.18. That seems well. Ah, Leife. What a start. Okay. We're back. As you can see, I have a little stream pause screen. Yeah. I'll bring us to the middle monitor though. We return to our natural selection simulation project. Where did we leave off? I don't exactly remember. Let's do a little refresher course in my own code that I wrote only a couple nights ago. Yep, I'm officially refreshed now. So we had, if I remember right, we've begun getting into multi-threading. We have our painter thread, which is going to handle just the window and the panel. So the painter thread holds the window holds the panel. Well, all right, the window, which the window class is a J panel and creates a J-frame window that gets displayed on screen, and then it takes care of all that stuff. And then there's the paint method. That's what we were working on. So we needed something to paint. We had just finished up, if I remember right. Not finished up. We were deciding. I was deciding how exactly I wanted to do this. And I think since then, I've had a few ideas. And by a few, I mean pretty much just the two of, do we send a call from each object to the window, or do we get a loop through the entire list of objects? And I think that's what we're going to do. Because if we have a separate thread calling this get, then it's not going to really be that slow, which we saw in the old deprecated simulator. Excuse me. So, given that, we are going to create a new method in our game object, abstract game object. We're going to call it public rectangle, because that's what we're going to be returning, get shape. Oh, wait, no. I has shape has get rect in there. Apologies. That's right. So I already created, so we kept I has shape. Oops, didn't mean to activate that. Oh, no, that's not a screenshot. Oh, no, what am I doing? I'm losing my faculties. Gotta get some water. Wow, it actually recorded the screenshot mode. I'm gonna screen dimension screenshot. Whoa, diamond. Anyway, now that I'm done being, yeah, we will go ahead. Let's see here. So So we're going to want to create. You see, here's where we have the question. Does the main method... Right, so our main class is going to hold our list of objects, our list of what's going to be the cells. Do we hold a list of I_shape or a game objects is the question. Probably a game object. Although every game object has shape. So we're going to want to get a game object. I_shape is just to sort things out a little better. So we are going to, after tick rate, create a public static, not final. Wait. It can be final, right? Because it is a constant list. We are going to create... Right. First, we're going to look up what is the difference between list, Java, list, and array list. Let's figure this out. List refers to a collection of various elements in a... Oh! Zeus. Zeus, why you gotta scare me like that? It's because Leifei's song was very quiet and nice, and then we got Zeus doing this out of here. We're gonna skip that song though. Not for any, not because it's bad or anything, but just because it's oh no, something went wrong with Apple Music, but that's my music. No. Which I still haven't gotten a playlist of non-copyright songs yet, but I'll just skip the songs that I think might be copyrighted. Holding Out for a Hero being one of them. If we get Holding Out for a Hero on shuffle. Okay, no, we got some Zed. Paper cut. Little Reliant K. Okay. A list refers to a collection of various elements in which every element is basically an object. Also, we can access elements. Okay. Okay. Array list lets us add and remove easily, which is something we're going to want to do. Look at that. Okay. Now, linked list. Let's look that up. Linked list and array list. Allows for fast random access, but slow iteration and deletion. Which allows fast iteration and deletion, but slow random access. Let's see here. Okay. Let's see. Two types of linked list. The key difference. For index-based access, but 0n for insertions are okay in contract. For time complexity. For insertions and removals, index-based actions. Which is fine. So we're going to want a linked list instead of an array list. Linked list, a game object. So we're going to want to import linked list, linked list, all objects is what we're going to call this. Import linked list, import a game object. There we go. All objects is equal to new linked list. And apparently you don't have to add that a second time. It's nice. Look at that. Thanks, Java 20. All right. So now that we have this linked list, and let me just be sure here. An array list. Free to add more. Oh. Interesting. What is a linked list? Are linear data structures like an array list. We're not required to specify any size. The objects stored here are not stored in contiguous memory like... Oh, so they're not stored in any particular order, which is perfect because I don't want them in any particular order. That is not something we need to know, is what order they're added in. We just need to know that they exist, and we need to reference them once they exist. So, things like all objects dot... Yeah, okay. Okay, alright. Okay. This is nice to know. And hopefully... faster. Random access. What is random access? Java lists. Marker interface used by list implementations. Memory inefficient. And the pointers. Okay, interesting. See, this is new stuff I'm learning. I've only ever really used array lists, not knowing these existed. Okay. Inserting values versus a linked list. Nice. Inserting the values of a linked list. Oh, this looks more complicated. I heard the connection between the nodes helps us greatly. What? Interesting. Accessing and searching values. Are more common when data reading scenarios are more common than adding or removing data. So we are caught in an impasse because we want to read both. See, we have a lot to consider here. There's pros and cons to both. And you need fast random access and don't need to do a lot of random accents. How much more memory though? And we do want to do speed more than anything. And it seems like if I do adding and deleting, it's not going to cause so many problems like it used to with the array list. See, again, we're caught at a certain impasse here. It's like, which do we want to use? I'm gonna say we're gonna stick with linked list and see how that works for us. Hopefully it doesn't just bombard my memory or anything like that. I could always go and try... Oh, whoops. Replacing it over here. In the old one. Replacing array list with linked list. We could try that. Nice. Linked list. Mm-hmm. That should resolve itself. Oh, right, because I have to linked list that as well. Okay.
You are, it seems, one with many skills. What a rare combination.
Linked list, linked list. We can try this. Ooh, yeah, Temanite's the master. Oops. Okay, here we go. Now that I'm done being a dumbass, we're gonna go ahead and see. Is this how it used to run? I'm gonna get linked list and replace it with array list. I'm gonna try this again. Okay, it did run like that. They could only move so fast. So we're gonna get cell count, and we're gonna call it 1,000 and see how this runs. It's a little choppier, I think. Maybe it isn't. Oh, not 10,000. Holy, that would have been bad. Let's try 2,000. There we go. There's some lag. We're gonna replace array list with linked list. Replace all, and run it again. Oh, well, that was fast.
You've come farther than most. But there's
Oh, whoops.
something you need to
Hmm.
I always get the last
And we're not going to worry too much about this. We are going to build our project with linked lists. Or, well, at least the cells are going to be referenced with a linked list. I'm going to check this message real fast. Respect some privacy. Alright. Massive sniff, bro. That's impossible. Okay, we are going to... We're going to make an attempt here. I think. Oh, no, you see? Again, it's a matter of making sure that we're constantly calling a tick method. Well, it could always add itself to multiple lists. That could be part of a game object. Is that when it's constructed, it adds itself to a different list, and that different list is going to be an array list on a different thread. Okay, so we're gonna run it with linked lists for now. So we're gonna go ahead and say that after pthread.start, we are going to do. And we're gonna make it, since it's static, all objects. Oops. If I could spell. All objects dot add. New a game object. 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 There we go. And a game object. A game object is going to, we're going to for now construct it with int x, int y, int w, int h. And then this dot x equals x, this dot y equals y, this dot w equals w, and this dot h equals h. Easy enough, right? And we're going to put it at 10, 10, and 100. 100 is going to be what we do it as. All right. Him, and it's not me. Cool. Now we're going to do painter thread. Sorry, the window is going to get main.allObjects. And main.allObjects. Ooh. There's that tutorial I saw on iterators on lambdas, and that might be useful here. So we're going to take a little tutorial break here. You can join me for this and learn about lambdas with me. I know a little bit about them, but I want to understand them more. This guy's really cool. His name is, actually, I'll pull you over to my right monitor. His name is Coding with John. Jonathan here.
My name's John. I'm a lead Java software engineer.
He's a lead Java software engineer, and he has a whole Java course down in this description. There it is.
Along with certain types of interfaces. So to understand exactly what a lambda is and when we can use them, we first need to go over a little bit about interfaces. You probably know
interfaces
is kind of like a contract that says that any class that
I do know what an interface is. Oh no! Oh, because the video. Yeah, okay.
Specified by that interface. So for example, if we have an interface like this one called printable, this print here is declaring a method called print, but notice it doesn't have any implementation at all. But the idea is that you can create a class that implements this printable interface. And when you do, that class has to provide its own implementation of the print method. So
yeah.
in our cat class,
Now, before I continue this, it seems my puppy wants to go outside, so I'm going to let her outside real quick, so we shall return shortly. Hang tight. I'll risk it for the biscuit. I'll rewind the song, and I'll leave the music playing.
I will never Take a good look at yourself and know you've got yourself a ways to go. But difficult is not impossible. You can take back all the lost control. Take a good look at yourself and see that you'll emerge eventually. As long as your heart's not too far gone from the only thing that can save you from yourself.
And I return. Thanks for Lion K for holding up the stream. Forgiveness can be given when you think it can, because with every passing second comes a second chance. Remember that, guys. Remember that. I say guys as if someone's watching. All right. So, we return to coding with John. Hello, John. The titular John. We're going to go back a little bit. Most likely the dog's going to want back in the room here in a bit. She didn't want to come in here, but she might later, and I'll have to grab her again. But in the meantime,
a class that implements this printable interface. And when you
Yes.
do, that class has to provide its own implementation of the print method.
interfaces
Over
are
in our
awesome,
cat
is what
class,
he's saying.
Inside the class declaration at the top, we can write
Implements
printable.
printable.
Now notice it's giving us an error here because we're implementing the printable interface, but we haven't yet defined our implementation of the print method. So let's go ahead and do that now. So
Makes
that
sense,
would be
makes sense.
Public void print that takes no parameters. So for our implementation to print out a cat, let's just print out meow. So now we can hop back here
Meow.
to our main method and create a cat. My cat equals new cat. And with this my cat, we can call the print method on it that we've just implemented. And now if we run our program, we can see that it prints out meow.
Meow.
But also down here, we
He
have
likes his
this
cats.
method
John,
print thing,
that is.
which takes in as a parameter a printable, which can be any object that implements the printable interface. And inside this method, it knows that whatever this thing is, it does implement the printable interface, so it knows that
Okay.
it's able to call the print method on it. So that's what it's doing here.
Makes
Since
sense,
our
yes.
cat class
It's
is
more
implementing
interface stuff.
print, we can
We're gonna go
instead
forward a little
call
bit,
the
'cause I
print
know
method
this.
and pass in our
And I
meow
can explain it to you
if we run
guys.
Our program, we get the same output as before, meow, because inside this print thing method, it's just calling the print method on the cat object that we sent in. Here's where lambdas come in. Now the only special thing that you can do with a printable is call this print method on it, right? Because that's the only method specified by this interface. So when this method takes in a printable, the only thing that really matters about it is what that thing's implementation of this print method is. But right now,
Right.
even though really all we want to do is provide a specific implementation of the print method here, there was a whole bunch of things that we had to do to be able to do that. First, we had to have some class implement the printable interface. Then we
Yes.
had to provide an implementation of that print method so it would print out what we wanted. Then
Lots
over
of
here,
steps.
we had to create a new object of that class. Then finally, we could pass in that object into this method as the printable parameter. Lambdas allow you to just pass in a specific implementation of this print method as the printable parameter without needing all of that extra stuff. So you can literally think about it like this. So let's go over to our cat class and copy the specific implementation.
This might be
of
huge,
this
guys.
print method that we want to use.
This might be
And
huge.
then over here,
I'm so glad I stopped for this.
calling
Thank you,
the same
Jonathan.
thing, and we need to pass in a printable. Instead of passing in this mycat object, let's just try and pass in the specific implementation of this print method that we want it to use. This gives you the concept of what we're doing with a lambda. Instead of passing in an object that contains a specific implementation of the print method, we're just passing in that specific implementation of the
Wait.
print method. And what we're
Let me
and
look
then
this again.
passing in this mycat object, let's just try and pass in the specific implementation of this print method that we want it to use. This gives you the concept of what we're doing with a lambda. Instead of passing in an object that contains a specific implementation of the print method, we're just passing in that specific implementation of the print method directly. When you're implementing a method inside of a
Okay.
class, it looks like this. But when you're using lambdas to pass in a method implementation as a parameter, there's some things that we leave out. First, the access level, public in this case, is not needed, so we leave that out. We also
Okay.
don't need the name of the method, we just need what it does, and so we can leave out the name too. We also don't even need the return type, which in this case is void, because the compiler can figure out the return type automatically, so we can get rid of that too. So now we're left with the only things that we really need to define a method implementation, and that is the parameters, which in this case we don't have any parameters, and the actual method implementation. Now to make this a valid Lambda syntax, all we need to do is add an arrow
Dash
operator
and an
here
arrow,
between
yeah.
the parameters and the method implementation. The arrow operator is just a hyphen and then the greater than symbol. And you can see that we now have no more errors because this is a valid Lambda expression. Now we can compile and
Which
run our
just
code.
not to diss on John here, the titular John of Coding with John, but if we're talking Greek, it is pronounced lambda. But you know, I don't want to be that guy, even though I just was that guy. I'm sorry, I had to do it.
And it does exactly the same thing as
Lambda.
before. It prints out meow. But instead of having to do all that work,
Poor
we
Englishmen.
implemented the printable interface inside the cat class, and then we defined the print method that we wanted inside that cat class, and then created an object from that class and passed that into the print thing method. Instead of doing all of that, we're instead just passing in the implementation of the print method that we wanted to use as our printable parameter. Basically, instead of sending in an object which contains an action, we're just sending in the action itself. We can actually simplify this Lambda expression even more. If the implementation that you're passing in is just one single expression, you can leave out the curly braces. And then you can have your whole entire Lambda expression just be one line like this. So notice that we're using a Lambda to pass in our implementation of that print method as an object like we would any other object. That means that we can save this implementation of the print method as a variable just like we could with any other object as well. So we can say printable lambda printable equals this entire Lambda expression. And then we can pass in this Lambda printable object into the method, and then if you run it, it does exactly what it did before. So lambdas in Java give you the ability to make method implementations into objects like any other that can be saved into variables and passed.
So basically, you pretty much just bypass. Oh shoot, I'm getting a call. Back to the waiting room. Oh.
Hello, ladies and gentlemen. Welcome to the party. I will be your host tonight. My name is Champagne Charlie. I hope you have a pleasant evening. But first, an introduction to how I like to live my life. And this is my instruction. Now, people have struggles that you can't see. So always be nice and never be mean. Be on time and have a good time. And always drink your tequila with lime. When you're happy, please do sing. But just remember to keep that straight. Always love and never hate. Now it's time to celebrate. Champagne, champagne, come on, let it rain. Oh, twist the cork and feel the pop, pop the bottle and bottoms up. Champagne, champagne, come on, let it rain. It's always time to celebrate, so let's all drink champagne. Well, I think you get the gist by now. So let us start the drinking. Let's have a glass. Or two, or three. I like the way you're thinking. I don't want to see an empty glass in here. So raise those bubbles high. Now happiness is guaranteed, but at least it's worth a try. Champagne, champagne, come on, let it rain. Oh, twist the cork and feel the pop, pop the bottle and bottoms up. Champagne, champagne, come on, let it rain. It's always time to celebrate, so let's all drink champagne.
And we return again, back to Coding with John, the titular John from Coding with John. Champagne, everybody. All right, let's. Okay, so if I understand this right, oh whoops, you basically can skip having to have an object if you just want to use. Oh, I think I just figured something out here. I think I might have figured something out here, but we're gonna let John finish.
implementations into objects like any other that can be saved into variables and passed into methods as parameters. Right now, the print method inside our printable interface doesn't take any parameters, but let's see
Right.
what it would look like if it did. Let's say it took in as a parameter some string suffix that is intended to just go at the end of whatever is printed. Now back over here in our lambda expression, let's go ahead and get rid of this cat because we don't need it anymore. Over here in the lambda
No, not the cat.
error. And that's because the interface method that we are implementing has one parameter, but our lambda doesn't. So all we have to do is give it whatever name we want it to use for that parameter.
So now my question is, when you put this lambda in there, you don't put in the name of the method, but there could be multiple methods. So how do you know which method to get? Is the problem? Or maybe it's not a problem. I don't know.
Could
Let's
use
keep
the
watching.
same name that it has in the interface and just call it suffix, but we don't have to. We can name it whatever we want. So we can even just name it S. And we
Nice.
don't have to specify the type here of string because Java already knows that
It's
because
a
the
string.
type in the interface is defined as a string, then that's what the type of this parameter has to be as well. And also, if you have a single parameter in your lambda expression, you can exclude the parentheses as well. But if it doesn't have any parameters or it has more than one parameter, you will need the parentheses. Anyway, then we can use this parameter however we want inside our method implementation. And you don't have to use it at all if you don't want to. Notice that we're not getting any errors at all here if we don't use S in our method implementation. But of course, we can if we want to. So it's a suffix, right? So what we can do is after meow, we can just append whatever that string is on the end. Since that print method now takes in that
Okay.
string suffix
Hold on, wait.
parameter, we also-
Let me send this thing real quick, and then I'm gonna replay that. All right. Because I'm curious.
do is after meow, we can just append
Oh, okay,
the
cool.
string suffix parameter. We also have
That's what I thought he
when
did.
we're calling
I just
that
want to make sure.
method down here. So maybe we wanted to use like an exclamation point as the suffix. So then we can run our program, and now it prints out meow with an exclamation point. Now, if you had more than one parameter, like over here, if we had
Oh, wait. I think I see. Okay. You are basically creating the needed method. Whoa. Okay. Because he's putting in lambda printable, which is okay. No. And then he's just passing that into print thing lambda printable. So he's just passing in the lambda. Oh, interesting.
exclamation point as the suffix in that string suffix parameter.
Okay, so it's more that backward stuff. So you create the lambda printable, and and the lambda printable determines what the function is when you call print when using that lambda. I'm calling it lambda now. When losing that lambda, wait. Oh no, I'm saying it right. I gaslit myself, man. I do it all the time. It's okay. So then you use that lambda, and then you have to use the input, and the input will be based on whatever. Okay. Great. I think I get it now. Don't listen to me. Don't listen to me.
So maybe we wanted to use like an exclamation point as the suffix. So then we can run our program, and now it prints out meow with an exclamation point. Now, if you had more than one parameter, like over here, if we had a string prefix as well, then over here in your lambda expression, all you have to do is just separate those two parameters with a comma like this. So we can use
Right.
like Q
Okay.
for the
Because you're
prefix
basically
and
just
S
shortening
for the
everything.
suffix.
All right.
So what happens if your interface method also has a return type? So instead of being void, let's say this instead returned a string. So now back here in our lambda expression, in order to implement that print method properly, we have to return a string object. And there are a couple ways we can do that. First, if your implementation has more than one line like ours did before, you can just put your return statement inside your implementation here like you would for any normal method. So you can just return whatever string you want, like meow. And in that case, we need a semicolon here and here also after the ending curly braces. But if your method implementation is only one expression, Java interprets that as being your return value, and you don't even need to use the return keyword. So if we
Wait.
wait,
Huh?
for any normal
Okay,
portion,
so
in order to implement that print method properly, we have to return a string object, and there are a couple ways we can do that. First, if your implementation has more than one line like ours did before, you can just put your return statement inside your implementation here like you would for any normal method. So you can just return whatever string you want, like meow. And in that case, we need a semicolon here and here also after the ending curly braces. But if your method implementation is only one expression, Java interprets that as being your return value, and you don't even need to use the return keyword. So if we wanted this method to just return meow plus the suffix and not print out anything to the console, all we have to do is make that expression into our implementation. So now this expression is our entire
is your
method,
return value.
and Java interprets that expression as the return value. So Java interprets this as meaning the exact same thing as if we use the curly braces and had the return keyword to return this value. But this just allows us a much cleaner way to do exactly the same thing. Let's talk a little bit about how exactly this is working behind the scenes, because I think it helps to give you a little bit deeper understanding of what's going on. Going back to our interface here, remember that we just have one method defined, this string print. When a method inside an interface has no implementation, like this one does, it's called an abstract method.
Right.
And when an interface has exactly one abstract method, it's called a functional interface. When you have a functional interface, you can even add an annotation here above the top of your class at functional interface. You don't technically have to have this annotation at the top of your interface for it to be a functional interface, but it is best practice to do so, because if you do, the compiler will enforce that you have one abstract method in your interface. So if we tried to add another abstract method to this interface, like
That's what I was wondering about, is like, what if you had two?
it's giving us an error because we're saying this should be a functional interface, but we're providing more than one abstract method. For it to be a proper functional interface, it can only have one abstract method defined. These are also sometimes called SAM interfaces because they have a single abstract method, SAM.
Sam.
This could contain
I like
other
it.
types of methods like
All right,
static
Samuel
methods
interface.
or default methods, and still technically be a functional interface. It just has to have exactly one abstract method. So what does this have to do with lambdas? Well, lambdas can only be used in the context of a functional interface. If an interface has more than one abstract method, then you can't use a lambda for it. So if we got rid of this functional interface annotation and added our void doThing method, now we have a problem over here in our lambda implementation. And it says multiple non-overriding abstract methods found in interface printable. The reason this happens is that in a lambda, you're only able to define the implementation of one.
So it's almost like a constructor at that point, like a class constructor.
Because Java knows exactly the method that you're implementing in your lambda because there's only one. So if our printable interface had two abstract methods, we would always be leaving one of them completely undefined if we were allowed to create them with a lambda expression. If you want to do something similar to this, where you have an interface with more than one abstract method, you can do what you need to with an anonymous class, and you can learn more about anonymous classes in this video here.
What?
From a technical perspective,
Anonymous class? Well, guys, you know, John has been so helpful thus far. We might as well stick with him. And I'm going to go ahead and get rid of all these tabs because I don't need them. That was stuff from a much earlier project. And, well, Opera Workspaces makes everything beautiful. This live stream was not sponsored by Opera GX, but that would have been really cool. And Opera GX is amazing. You should get it. Yo, Blue, what up? How goes it if you're still here? I didn't even notice the comment there. Oh, I have to sign in on here to chat. Can I do that? Oh, here. Let me make sure I'm not, like, exposing myself. Let me not expose myself to Oh, I can't do it from inside. Okay, I see. In that case, let me go over here. What up? Nice. I mean, obviously you can see that anyway. Oh, whoops, I'm on the middle monitor. Oh, what up? All right, John.
is a
So let me listen to what he said about
something
abstract
similar
classes.
to this, where you have an interface with more than one abstract method, you can do what you need to with an anonymous class, and you can learn more about anonymous class.
Okay,
So
again.
if our principal interface had two abstract methods, we would always be leaving one of them completely undefined if
right.
we were allowed to create them with a lambda expression. If you want to do something similar to this, where you have an interface with more than one abstract method, you can do what you need to with an anonymous class, and you can learn more about anonymous classes in this video here.
Okay, let's learn about anonymous classes, guys. It's a 6-minute video.
We're going to talk all about anonymous inner classes.
And by guys, I mean you, Blue.
How they relate to Bigfoot. My name's John. I'm
What?
a Java software engineer, and I love
Where did Bigfoot come from?
sharing what I've learned in a clear and understandable way. So be sure
Bigfoot,
to
bruh.
so you don't miss each new Java tutorial. I also have a full
Thanks.
Java course, one of those
All
things
right.
in Java that just has a scary sounding, complicated sounding name. Anonymous
Yes.
inner classes. It sounds really hidden and
Anonymous inner class. It does. It's awesome.
It can be really useful and really cool to use. An anonymous inner class is a class with no name that you use to instantiate only one object ever. So whenever you use an anonymous inner class, you'll always be defining that class and instantiating the single object of that class at the same time in the same Java statement. This will become a whole lot easier with an example.
What?
Your anonymous inner class can either extend any existing class or implement any existing interface. We'll start with the one that extends another class. So let's say we have this type animal, and we want to create a new object of type animal. We'll just call it
Oh.
my animal equals new animal. Just your basic constructor to create a new animal object, right? And if we hop over to this animal class, we can see that it just has one public method.
Yap. Me.
Of course, if we took this my animal object and called the make noise method on it, of course it would just print out yap. What if we wanted to create a new type of animal object, like a Bigfoot, that there is only ever going
Oh, that's why Bigfoot was involved.
to be able to make noise in
Damn
a
you,
completely
Bigfoot.
different way than a regular animal object? Well, we can use an anonymous.
Is
inner
Bigfoot
class
an animal?
to
That feels a bit
starts out
rude.
looking like any other constructor call. Animal Bigfoot equals new animal. However, if we leave it like this, we get a basic plain old animal object. If we want to define our own new type of animal here, we just have to put an open and close curly braces. And inside these
Oh
curly
yeah,
braces,
this.
we put
I've used this before. I just didn't know what it was called.
here is creating an anonymous subclass of the animal class and writing that
An
class down
anonymous
right here.
subclass. Okay.
Animal class, we have
Anonymous because it's not already defined in the compiler.
we can override this make noise method with our own
And not the
implementation.
compiler, you know what I mean.
Void make noise. Now, of course, we want to have it make noise like a Bigfoot would. System.out.println. Perfect. Sounds exactly like Bigfoot. So now if we take this Bigfoot object.
Oh, John.
Make noise on it. This regular animal object, my animal, still says yap, but our Bigfoot says. This is
All right,
what
John.
anonymous inner classes allow you to do. They allow you to
We love you.
create an unnamed subclass of some other class like animal and create one single object of that anonymous class. So of course it makes sense to use an anonymous inner class to create a Bigfoot object. You know, a Bigfoot object is mysterious. You can't go around as a Bigfoot object with a big old, class name of Bigfoot on your forehead, and you can only ever create one of them. We created this one-time use anonymous inner class as a subclass of animal. So now later on down in the code, because this class that I made doesn't have a name, I can't just instantiate another object of that.
Oh.
I mentioned that there are
Okay.
different ways to create an anonymous inner class, and one creates a subclass of an existing class like we did here. Another way is by implementing an interface. But the concept is the same. You create a one-time use class that implements an interface that you specify. One interface that you might be familiar with is the runnable interface. You use the runnable interface especially
Oh, like creating a new runnable thread.
program. By the way, click up here if you'd like a great video on how to use Runnable to create a multi-threaded Java program. But usually when you want to use a Runnable to create a multi-threaded Java program, you have to create a whole separate class file that implements the Runnable interface, and then you can finally create an object of that type and get your new thread running. Instead, you can use an anonymous
Or
inner
extends
class to
thread.
make it so much easier. To do that, we can say Runnable, my anonymous runnable equals new runnable. Now, of course, Java is giving us an error here because we can't instantiate an interface. Runnable is an interface, it's not a class. So what we need to do is create an anonymous inner class here that implements the runnable interface. So we'll do the same thing we did above and put in our open and close curly braces. Now Java knows that we're trying to create an anonymous inner class that implements the runnable interface, and it suggests to us here that we need to add the unimplemented run method to properly implement that runnable interface. So let's click it and do it. When you implement
There we
the runnable
go.
interface, you have to add your own implementation of the run method.
So it's just the same thing, but you can do it with...
Because we're overriding the animal classes method here. But back to our runnable, it might look like here that we're creating a new object of a type runnable, but we're not. Remember, you can't create an object from an interface. You can only create it from a class. So even though
Right.
it looks like we're creating an object of a type runnable, we're really creating an object of a class type that doesn't have a name that we're creating here. And that's the same up here. Bigfoot isn't technically an animal object. It doesn't have the type animal. Its type is this anonymous subclass of animal that doesn't have a name. But now we can take this my anonymous runnable object and call run on it if we want. Run that, and we get our yap 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 from our animal, our from Bigfoot, and I'm an anonymous runnable from our anonymous runnable object. And again, check out that multi-threading video if you want to be able to use your anonymous runnable objects to create a multi-threaded Java program. So an anonymous running class can be really useful if you want to create a subclass of some other class and you only ever need one object of the subclass that you're creating. Like we wanted to create Bigfoot as a new type of animal that makes noise in a different way, but we'll only ever need one Bigfoot.
Okay, cool. So this is just, and Lambda's a different way to do that, but with an interface that's created as its own separate class in your project.
Technical perspective,
Okay.
all a lambda is a shortcut to defining an implementation of a functional interface. So here we have a functional interface, but instead of having to create a class that implements that functional interface and then adding the implementation that you want of that single abstract method and then creating an object of
That's
that
pretty
class
powerful, I
using
think.
that, you can instead just
It's
simply
just a
create
matter of
Lambda
where to use it and
expression
how.
that contains the implementation of that functional interface method that you want. It allows you to effectively treat code as a parameter. If you enjoyed this video or learned something, let me know by leaving a like and
That
subscribe so you don't miss.
sounds to me like what's it called? Delegates in Unreal Engine. Event delegates or delegates or dispatcher, event dispatchers. That's what that sounds like to me, and passing delegates as variables. Delegate, not delicate. Although that would be pretty funny too. This little delicate variable. Let's continue our music, shall we? Back to Champagne. Come on, let it rain. All right. So with this in mind, I had the idea of running through a functional interface for each object, because each one would take in like a cell, you know, or a game object in this case. Interesting. But at that point, is there really a point? Or could you just call... I'm sure there's uses for it. I think I could do it in just the normal way and it wouldn't make a difference. I'm part of the sniff. So in this case, here's what we're going to do. First things first, we got to make sure we're drawing things right. I think that we're going to create a for loop, and for loop is going to have a game object. No, it's going to have I has shape. So we're doing something different. For I has shape, using main.get or .allObjects. Or do we want to get a copy of all objects? Can you just copy clone? Returns a shallow copy of linked list. Yes. So we're gonna create a clone of it. Cannot iterate over and oh, wow. Wait. But clone should call a linked list, or should return a linked list. Right? No, it clones an object. Linked list. Well, wait. You know, we're not going to worry about cloning it. For now, we're just going to try this. For I hash shape I, we're going to do I dot get wrecked. Although an I has shape, we're going to also return what kind of shape it is. Default. No, not default. We're going to return... We are going to return... Huh. For I has shape, we're going to do default public rectangle or so I want to also return whether or not the actual shape of whatever object this is going to be a circle or a square, because sometimes we'll want to do a circle, sometimes we'll want to do a square. I want to get that per object. So we're going to do, oops, public, no, not public. Static, that's what I'm thinking of. Sorry that I was bald there for a second. Private static, because it's going to be private to each object. Private static. And we're going to create a new enumerator as well. In primitives, we're going to create an enumerator called shape. And shape is going to have square and circle for now. If we wanted to add triangles, I'm sure we could, but we're not doing that right now. Public static shape, and shape is going to be shape from com.primitive.main.primitive.shape. And we're going to do shape equals. Well, does it need a default? Only public, static, and final are permitted. So I guess static shape may not have been initialized. So it needs to be initialized first. So by default equals shape dot square by default. Hell yeah. So now what if we do I dot shape? We're gonna call it public static then. No, I want it to be private. I wish it could be, but it can't be. I guess it could be public. We don't mind public. Accessors for this, and we're gonna do default. No, we're gonna do yeah, default public. Oops, public void change shape. So we can call change shape if we want to, and shape is gonna take shape, and it's gonna be this dot shape equals shape. So now cannot be assigned. I has shape dot shape equals shape, bruh. The assignment to be assigned. Interesting. Here's what we'll do then. We're gonna do it this way. Public shape get shape. And so that means every single A game object is going to have to return add unimplemented methods get shape, which is going to at first return null. But I don't want to return. We're going to skip the rest of this. What did we get? Oh, there we go. Oh, nice clarity. Okay, so for this, instead of, I almost want to. Can I make this abstract? Abstract. Oh, public abstract class. There we go. So now it not only implements, although if I'm correct, since it's abstract, we don't have to implement. Oh, right, I removed abstract earlier so I could quickly bring those back in. Cool, so other objects will have to get a game object. Right. And then do shape. And we're going to create a protected shape. This dot shape equals shape. And I guess we will go ahead and implement get shape public at override. Yeah. Override public shape get shape return shape. Return this dot shape. Oops. This dot. I want to put this dots everywhere. Oh yeah, and I have to finish it as a function there. There we go. Which means we're also gonna have to do shape dots. Let's do shape dot square first. I cannot instantiate it because it is a. Yeah, so we're gonna do. Guess what? A game object. Which goes with A equals new A game object. Add arguments. And right now it doesn't need to implement anything strange there. And we're going to add A. There we go. Look at that. Although we don't really add anything here, so we're just going to do it like that. So now, you see, now we're on to something. So now I has get shape as well. So we're going to do window. We're going to go ahead and do g2d.draw. And we're going to call this E-shape. Refactor rename so we don't get it confused with the normal one. So we're going to g2d.draw. We're going to go ahead and do a thing here. G2D. No, we're going to do, and what does it return? draw methods don't return anything. They're all void. So we're gonna do void draw. We're gonna do private void draw object. An object is gonna take rectangle rect and shape. And we're gonna have to implement both. And we're gonna switch on shape. Case shape dot square break, and case shape dot circle break. Oh, it's E shape. My bad. I just changed it to import E shape. I'm sure there's already implementation from the actual shape there. Oh. Oh, nice. And we're going to do case default as well, just in case. And we're going to break that as well. Oh, it's not a case, though. It's just default. So now we're going to go ahead. I do want to try shape. S equals new shape. And we're going to make an anonymous inner type of shape. Interesting. We're going to undo that, though. I just wanted to look at what shape looks like, the Java shape. So we're going to do draw object I dot get rect and I dot get shape. Nice. So on square we're going to do oh, I guess it's more of a G2D thing. So we're also going to get graphics 2D, G2D. We're going to return G2D. And we're going to do G2D dot draw rectangle. I guess that's draw shape, isn't it? Or is it just draw? And then we're going to do this here, and we're going to do draw. Or no, wait, it's fill. Fill oval. And fill oval is going to be rect dot. X rect dot y rect dot w. Oh, more Temanite. Width and rect dot height. And then by default, it's just going to be a square. Cool. So now we just separate it there so we can have something a little easier to go by. Okay. I'm liking how this looks. It draws, baby, it draws. So now let's add another object. We're gonna do A, A2, A3, A4, and 2, 3, and 4. We're gonna make a much smaller one, and I'm gonna place it at 800. We're going to place one at 100 and 500. That's going to be 50-50. Haha, 50-50. And then we're going to place one at like 1,000, 1,000. That is going to be 10-10. Actually, we're going to call it, and then we're going to make this one a circle, and this one a circle. Yeah. Now where's my other circle there? Is that too far off the screen? I'm adding A4. I'm gonna do 15-15 for the size. There you are. I'm gonna try 800, 900, 900. Maybe 1,000 is too far. Okay, that's odd. Square. Circle. Let's not add any of the others and just add that one. Just doing a little debugging here. See, A4 is nowhere to be seen. Did I just miss it because it's at the very bottom? No? Oh, because it's not 1,000. It's not 1,000 wide, I forgot. It's gonna be a lot less than 1,000 wide. There you are. Cool. Okay, we're gonna create object constraints in a game object. But we have created our paint method, and hopefully this isn't the worst thing in the world. So we're gonna leave this here just to keep testing a game object. We're gonna add one more. And we're gonna call him Bad Boy. And we're gonna add Bad Boy. And Bad Boy is gonna be all the way over at 900. 900 isn't enough. We're gonna make Bad Boy square. And we're gonna make Bad Boy 50 by 50. And Bad Boy is gonna be 750 low and 111 to the side. There you are. Look at that bad boy. He's clipping into the. He be clipping. That's not allowed. He's not allowed to clip. So now we got to keep him from clipping. But how? How do you do that? Please, Mr. Ferrix, tell us. Well, my beautiful boy. Painter thread is perfect. It does everything it needs to do. We're not going to worry about it anymore. Sorry, that was a separate thing. Although, we do need to get all of these. The painter thread, and supposedly getting everything is not good. Huh. We're not going to worry about it yet. If things start getting slow, we will. Because that's not going to be too hard to change. As long as we're building with multi-threading first, then we'll be fine. Also, I'm eating Skittles gummies. Which is why it sounds like there's something in my mouth. Because there is, as a matter of fact. Okay. Is this copyrighted? It probably is. Honestly, Reliant K probably is too, but it's too banger to not. Okay, a game object exists as well as its constructor. We're gonna go ahead and create. We're gonna create private void constrain. Private void constrain. And then we're going to call this dot constrain. So for now, constrain is going to be constrain initially just keeps it from going off screen. But what I did in my program is that if they went off screen, they would end up on the other side of the screen. So it's like one big round map with it's like a sphere, you know, like the world. It ain't flat, or maybe it is. Who knows? I don't think it is. At least not last time I checked, anyway. Okay, I'm laying all the way back. My thinking position. We're gonna go ahead and implement it like it'll switch. I also want to get public dimension, get pause, no, get center, although we can get center with eye shape, now that I think about it. It implements it anyway, right? So we're gonna do, after get pause, we're gonna do public. Oops, I wanna flip these. Default public dimension get center. And we're going to basically just do return new dimension. And dimension is going to be get x. It's going to be this dot get x. And this dot get y. But then we're going to add on to them this dot get w divided by 2. We're going to put that in parentheses just because safety. You know, I know division happens first, order of operations and all. We're going to do this anyway. Oh, yo, Sonic. And then get height. And then whenever get center passes by the bounds of the screen, which screen bounds is going to be another constant in main. It's going to be a main constant. Is it going to be a main constant? No, it's not. It's going to be a window constant. Because we're getting these bounds. So we're going to do public static int, actually public static dimension get bounds. So the bounds are obviously going to be, you know, 0. You can't go below 0 on either x or y, but then we're also going to return these. It's going to be so we're actually going to basically just append this here. We're going to append that. We're going to actually indent that. And then the size. Although, if I'm correct, turn frame dot, well, frame we create here and it's private. We're going to create it below frame, so we can just use frame instead of all this. Public static dimension get bounds. Then it needs a return method. The static method cannot hide the instance method from component. Doesn't mean it has to be below the constructor. Cannot hide instance method. Instance method. Oh. Okay. Override. Okay. Hold on. I gotta think now. We're gonna call it get limit. Instead of bounds. Get limit. And we're gonna return frame dot. We can't refer to a non-static field. Cannot make a static reference to the non-static field frame. I don't really want it to be static, because then that changes.
I know that we are upside down, so hold your tongue and hear me out. I know that we were made
So you see, here's where we have some more issues. I'm gonna check this message while I do a little thinking, a little noggin thinking. And then, let's see. I am gonna stay the night, Haley Williams. We are going to window dot frame dot get size. No. Okay. We are not going to do that then. We are going to do it like we were originally doing it by creating all this. And we're going to put it above here. Now we're going to put it over here. Get bound still isn't a thing, right? Yeah. New to new dimension. So we have our width and our height, and then we're gonna do h equals h minus h divided by 4, and then w will equal w divided by 4, w and h. So now I want to system.out.println just to see. We're gonna do window dot get limit. That looks about right. So now, using get limit, and we can get rid of window there. We are going to, now that window has this, we are going to, let me look at this. Again, this is fine. This is beautiful. We can get rid of that. Was it an eye has shape? No, that is get center. A game object has constrain. And it's going to do, see, we have a lot of things we could do. We're just going to do, instead of nested ifs, we're going to do a bunch of ifs. So we're going to do if this dot x equals, this dot x is less than 0, if this dot x is less than y. So we're gonna do this. We're not doing else's because we want to do all of this at once. Because because it's not going to be both less than 0 and more than the limit. So this dot x is more than window dot get limit dot x. I guess dot width. And then we do the same thing, but with y dot height. Okay. So with this, we have created our, I guess, blueprint for making this function. And then we're going to say this dot x equals, ooh, right. What if I do set center as well? What if I make a set center variable? Not in the interface because it can't really set. The interface is not supposed to set anything. It's only for getters. So I could do set center here, but I don't think I'll ever need to set center again. So we'll just create it ourselves. We'll just do it manually in one of these. We're gonna do so let's see. Let's just think about it. I'm thinking about it in the corner right now. I need to be thinking about it in just the one dimension, not two. So if you were to approach and you were to go one behind the line, it wants to set you, it wants to center. And right, let me do this dot get center dot x or dot width, since dimension calls it width. Which I don't like at all. But it's what we got to do. Even though it's not a width and a height. Let's see here. Is position a class within a document? Java.awt Java.awt.dnd here dot sorry awt dot not here. Let's do get center dimension Java awt. Let's go to declaration. There's awt. Holy. Okay, so we have color composite. What is a composite? Let's find out. Interesting. Event container. That is a lot. I'm not even gonna look at that. There's font. There's dimension. I wish there was a double. we're not going to worry too much about that. We are going to do this dot get center dot width. We're going to let it be width and height. Or we create a primitive class called XY. We could. We could do it. But I'm not going to. We're not going to do that. We're just going to leave it at width and height. That's fine. I can deal with it not looking perfect because again, it's I can read it. So if this dot get center dot x really. Then again, I could just create a new dimension. Make it a subclass of dimension. No, I'm creating a primitive XY. We're gonna have some fun here, guys. XY. This is what I did in the last one. Oops, caps lock. XY has a private. No, has a public int x, public int y, then public xy, and it's just gonna xy. If you make it, it's just gonna be this dot x equals 0 and this dot y equals 0. Makes it with 0 by default. Makes sense, right? And public xy, int x and int y. This dot x equals x and this dot y equals y. Then we're also going to do public. For some reason, there's getters and setters for dimension. As a matter of fact, we're going to go and look at that real quick. It has width and height. Dimension, you can also just get a dimension in dimension. That makes sense, actually. And then we're also going to make one from dimension. There we go. Okay, we're gonna look at this real quick. So it does have a get. Oh wow, that's cool. Good size. Even though that's just returning the dimension. I guess it's not returning the dimension itself. All right. Apologies for my little ADHD tangent there. I guess we'll have public get x. Public get y. All right, they need to have ints. We'll get public set x. Public void set x. Public void set y. Based as song. And then we'll also do public dimension as dimension. We're going to return new dimension. And we're going to do this dot x, this dot y. Return this dot x. return this dot y. We're gonna do int x, int y. Whoops. Int y. Need to add a semicolon here. This dot x equals x. This dot y equals y. Alright, get x, get y, set x, set y, and as dimension are all there now. We're going to do d dot get width and then d dot get height. Oh, I get it. It's giving doubles. Alright. And so I guess in that case, we'll return doubles of this. So if I were to open dimension back up and take a peer into it, they're both ints. But getting them returns a double instead. Okay. I was wondering why that existed. I always forget to, and I'm going to forget again and then see it and be like, oh, that's right. xy.x and xy.y. Perfect. And I want to put this one up top. There we go. Now we have an xy, which functions like dimension, but better. Oh, and I guess I'll go ahead and do a toString, public toString, public string, toString, and we're going to do return this plus this dot x plus that plus plus this dot y plus the end square bracket. So now we even have a little formatting for how it looks when printed. Okay, now we're going to go back to I has shape, and I also want to go back to window. Window just fills with rectangles. So in that case, I as shape. I'm going to do XYs. New XY. New XY. Perfect. That's better. Dot X. Dot Y. Dot X. Dot Y. Look at that. Looks cleaner. I like it. I can add my own stuff into XY now. Little things like that always help. I can add like randomizers here too, like get random XY, which is something I do want to do. Which is something we'll do now. If you get public XY, actually creating a public XY without any constructor is going to return Here's what I'm going to do. Public XY random. Bound X and then int bound Y. Nice. So random R equals new random. We all know the good old random class. Makes things fun. Return r dot next int. Oh wait, no. We're gonna copy r dot next int so we can use it. New xy. Actually, we're gonna return this. And we're gonna do this dot x equals r dot next int, and this dot y equals r dot next int. And then we're gonna do bound x and bound y. We're gonna do bound min and bound max, and they're both also gonna be xy's. But we'll also make an option for this using all ints. We're gonna do int x min, int x max, int y min, and int y max. Any. We're gonna do bound min dot x, bound min dot x, and bound y dot x dot, oh no, bound max dot y. I'm getting a bit confused. Dot x, my bad. And then we're gonna grab these and pretty much just paste it and replace them with y. X min, x max, and then we're gonna do y min and y max. Now, here's the thing. Random next int is origin and bound. Between the specified origin, which includes the specified origin, and the specified bound, which does not include the bound, which is really good for arrays. But all right, had to respond to a message. Okay. This is good. Yeah. Let me just make sure I've got this right. We can even create combinations of these, but I'm not gonna. Do I want to do inclusive? So it can really be between all of them? I think so. We're gonna add +1s to all these, so it can really be between all of them for xy's. Okay, that was a lot, but it created and finished our xy class, which is just gonna replace dimensions, so we don't have to use dimensions everywhere. Now, also, a game object can also include using xy's equals xy dot x and xy dot y. And we can also include that for xy wh and this one we have xy wh as just this, and wh dot w and wh dot h, or well, dot x and dot y, my bad. Although width and height is a dimension, so we're gonna do that. Dimension, and I know swapping between them is probably not the best, but it just makes it easier to read and easier to manage. So wh.height. There we go. So now we have a whole bunch of constructors. And I'm gonna make notes on all of these. Constrain. Now we make it back to our constrain method. So we're getting the center, and if the center is less than 0x, we are going to want to set it to the max bound. So this dot x will equal window dot get limit dot width. And then do the same thing here. But we're going to set it to get window limit dot height. And then do the same thing here. This dot x equals 0. And this dot y equals 0. Now here's the question. If I made a 2 pixel square, it's really hard to see, but you can see it there. We're going to make it, 2 pixel square. We're going to put it at 0, 0 and see what that looks like. Okay, and then if I were to constrain it to 1s, is it invisible? Does it have to be at least 1? Nope, you can barely see it. You can barely see it there. There's no way to zoom in, so yeah, just know that you can Oh, look at that. Look at that. That's wildly interesting, actually. Very, very, very interesting that it did that. Huh. Anyway, we'll put you there. But now we got to make sure that we're doing this by the center and not by the corner, right? We don't want to set the corner x. So x is going to be the window limit. So the left corner is going to be, top left corner is going to be at the start, basically the very end of the window, the very right side of the window. So we want to subtract half of itself, right? We're going to subtract even better. This dot get center dot x minus window dot get limit width. Because if the center, let's say, we're going to do a little math here again. Let's say that the center, let's say the window is 100 by 100. And let's say that the center is at 110. But the left corner is set to that 100. Then we need to subtract it by that many to get it to the center. Boom. Oh, whoops. So, but now here's a question. What if it's an odd number? It should just be returning a rounded value. Uh-oh. Let me go to IS shape. Get center. It's getting it divided by 2. I'm trying to think here. Do we want to worry about it? I probably should. But I'm not going to. It should round up on its own. So now, we do the same thing here. this dot get center dot y minus window get limit height. So now, what do we do for the other way around? Well, let's do some math again. Let's say that the location, it passes the location in the center. And so now we want the center to be at 0 instead of the left corner. So while the left corner is at 0, the center is going to be at -10, so we need to add 10, right? So if we get, it should be get 0 minus wherever the center is. 0 minus the center. So 0 minus this dot get center dot x. And this should be 0 minus this dot get center dot y. So it's basically adding on at that point. If it's in the negatives, it's adding on. So now you, sir, should be up here. If I made you a little bigger, that's curious. Oh, right. We're gonna do thread.sleep for 1 second. And we're gonna go ahead and surround it with a try and catch. And then we're gonna do badboy.constrain. Well, constrain is a, I'm sorry, constrain is in here, and it's also in all of the A-game objects. So, actually, what happens if you call super? Hold on, I'm being retarded here. Oh wait, I'm not allowed to say that anymore. But that's not super, that's this. Oh ho ho ho, baby. That's right, I can do it like this. Well, like this. WH dot width and WH dot height. Although that's really just going to be called size at this point. And it's just going to be X for this and Y for this. Look at that. Oh, that's way better. So now it doesn't matter how we give it. There we go. We are going to go ahead and make this public just for a bit, so I can try constraining it again. Badboy.cont constrain. And we're not going to call constrain here. And when we do constrain, oh, infected state is huge. System out print line constrained. So one, and then it says constrained, but it's not changing. The body of the deceased. These are mutable. These are mutable, and iHashShape just returns all those. We are gonna go ahead and override this. iHashShape, we're gonna get wrecked. Nice. We're going to @override get wrecked. We're creating an anonymous inner class, guys. And we're going to system dot out dot print line. This rectangle. R rectangle R equals new rectangle. There. We're going to do 100. 100 is going to be its size. Constraint didn't change anything, even though it's clearly halfway through. We're also going to change get center. Override. Center. And then we're going to return super get center. We're going to system dot out dot print line. Man, my allergies are bad. Super dot get center. So we're actually going to skip out on this print line here. We got it 4 times when these are all called. Get center is for some reason just returning, oh, it's returning 800, which is perfect. But aren't the bounds 800? Let's go to window and we will system dot out dot print line. I'm going to do W plus H. We're also going to add some space. There. $8.10? Interesting. Is it really 810 wide or long or whatever? I don't know. Let's push it forward. 800. Well, that didn't seem to change much. Okay. Let's bring this back. It never changed. It did change it, supposedly. It changed to negative 850. Right. Let's see why that is. So it's more. It's going to set it to... Oh. We gotta set to this dot x equals 0, and then this dot y equals 0. This dot y equals window dot get limit dot height, and then same thing here, but with x and width. So we set it, and then we set it again. There you are. Let's put it at 750. Which should be, again, giving us... It looks like it's overlapped way more, so maybe the window height and the panel height are different. So that's what we're going to do. We're going to go over to window, and instead of getting this, because that's what we're setting the size to. Frame.pack. Let's call frame.pack. Well, maybe that wasn't the best. That wasn't either. Maybe we pack it before we add. No. We're gonna do this dot set size, and then we pack it. We're gonna do frame dot set size, and then we're gonna do this dot set size after we add this, and we're not gonna pack it. Okay. So we're doing it based off of. Oh. Interesting. I think we're doing it based. Oh no, not the slow music. It's gonna make me fall asleep. Ooh, underwear. No longer you, by all means. Okay, we're getting the width and the height of the monitor, and we're doing this little splitsies. Like how we did here. Like how we did before. But for some reason that's not working. So instead, can we return this W equals this dot? Cannot do this because it's not static. What if we made static versions? No. So there's problems here. There's clearly problems. I'm gonna make it at. See, the problem is it doesn't get sized. Right. If we add, we know the constraints are 1150. So we're going to set this guy to 1050 since he is 100 by 100. See, that doesn't look right now, does it? It's almost like it's flipped. Great song. And the location as well, I think is what we gotta do. Minus an additional width divided by 8. Minus an additional width divided by 8. Let's try this now. That didn't seem to want to work. Ooh, well, hello. The size has to be this, right? Let's do this, and then do it again with, whoops, copy this, paste this, Copy this. Paste this. Oh boy, what did I do? One too many, one too little. I guess I gotta surround these. There. So we get, yep, one, well, 14, 40, and 8, 10. Oh, right, we were printing the wrong thing. So this should be 13, 40, and it should touch the edge. Yes, but it's squeezing into the edge as well. Again, almost as if the bounds aren't actually the bounds. Because I don't think they are. So, I'm going to add the additional width divided by 8 minus width divided by 8. Divided by 8. See, okay, so that one does that. We're gonna make it to where this is 700. So the center should not be in there, and yet... Okay, we're gonna remove some prints here again. We're gonna remove these debug prints, and we're gonna remove this debug print. Actually, we're gonna keep it because I want to know where it assumes the center is, and then wait. Yeah, that's just telling us the supposed bounds. So the supposed bounds now are 660, 1200 and 660. So if I do... See, that's definitely not right, because now if I do 600, the center's going to be not over 660. So if I do 620, it's going to be over 660, and then it's going to create itself up there, even though that's not there. So what am I doing wrong here? Let's learn ourselves a little bit. Let's do a little learning. I want to get the height and width of like the frame, but the frame I can't get while it's static. But I want it to be static so I can call it from anywhere. But I suppose for as long as it is. Ugh. Okay, here's what we're gonna do. I'm gonna try again and make these actually equal a thing. So we're gonna do this. They're not gonna be initialized. It's gonna pass errors. We're just gonna say they're initially 0. Everything is bound to nothing. We are going to cry ourselves to sleep. We are going to remove this. Instead of getting graphics device, You're welcome. We're gonna sip some water. We can't get frame in a non-static context. And then if we make that static, oh. Okay, dot get width. frame dot get height. Let's see here. There's a possibility this could work. That is the supposed constraint, the one we had before. But if I put this at 700, it's being cut off, but not by the center. If I put it at 750, no, sorry, what's 810 minus 50? It's 760. So if I put this at 750, it shouldn't look that covered. I think I recall having this issue. What I don't recall is how I solved it. So let's go look, shall we? Set size to size, which was called in main, and main got it from window size. Nice. Okay. Then panel. This dot set preferred size. Get size. You see? It'd be interesting if I could do window.getWidth and window.getHeight. Can I make a static reference to the non-static method getWidth from JComponent? Can now make a static reference to the non-static method getWidth. Yo. Okay, let's put it back to frame. Set preferred size. I don't know what the difference between preferred and... I'll just copy these new dimension. There. Well, at least the song is really cool. Let's make it the size and the preferred size. And try that. Is it a math thing? Is it because of this? Is it not counting this bar? A game object. Clamp XY. So Y had to be 5 pixels. So the width minus this thing's size times 2. What the heck is this super complex calculation I'm doing? What if I just drew this square at 1440, 810, and it's 20 by 20. There's nothing. And if I removed 20 from this, making it 790, and making this one 1420, nothing. Let's just make this one 500. You just see a part of it. So if I remove another 20, bruh. See, I'm not sure what exactly it wants. Well, only one thing to do. Troubleshoot. Which is something I will do off stream, because this has been long enough as it is. I will go ahead and look up... Oh, look at that. Warrior of the Mind. I'm going to look up how to fix this thing, and then next time I stream, it'll be fixed, and we will continue on with the actual cell function, like creating cells and whatnot. So yeah, farewell for now. Woo.